So for makers out there who are looking to bring their product into production, but are also making medical devices who want to look at AI, maybe distributed AI is a solution for you. Here I am joined by Eric from OctaiPipe about their new solution for distributed AI. Go away.
Absolutely. So OctaiPipe is a next generation EdgeAI platform. What this means is that we're focused on the ability to deploy and train machine learning algorithms over very large numbers of distributed IoT-enabled devices. But at the core of OctaiPipe, if you're going to take two things away from it, is that we have two special technologies, one called Federated Learning and the other one called EdgeML Ops. So I'll start with the first. Federated Learning is a new paradigm for training machine learning algorithms in distributed environments. Originally this kind of stemmed out of concerns around privacy and security, particularly in sort of healthcare and financial services.
So if you're sending data across networks and stuff, that's sensitive to the person who's
exactly, yeah. Centralizing data, centralizing raw data about people in particular is a big concern. But of course in industrial applications we worry about industrial espionage, competitive leakage and so forth as well. So Federated Learning, instead of taking all of your data off of devices, putting it into some central data store, training an algorithm and then either streaming data for prediction or deploying the algorithm back to the device, what we do is we kind of flip that on its head and we pre-build a program with all of the steps to train a model for a particular problem, and we deploy that down to many devices in a device population to learn a particular task. And each device trains or learns an instance of a model each.
Would that be fair to say it's edge computing, basically?
Exactly. So we're doing learning on the edge, and so each of our, let's say, 100 devices now has its own version of this learn model for this problem. But then what we want to do is build what we call a global model that represents the learning across all of these devices, because these models can be, they can perform better, they can be more generalizable and so forth. So we now just return a few kilobytes of data in a message packet back to a central server where we have an aggregation algorithm that combines the learning, if you like, across all of these contributing devices. And this global model can then be redeployed back to our device population. So we can collaboratively learn a task across devices without moving the data off them, and we can keep that very private and secure. It really minimizes your data costs because you're moving very small amounts of data, a few kilobytes around over the network. The processing needed in the cloud is much smaller, and if you're working in remote environments where you can't guarantee good quality, high bandwidth connection, you're less reliant on the network and the cloud for your on-device intelligence, which is presumably doing something quite important for you.
And I suppose that's quite useful, especially in a hospital environment where you might have thousands of sensors operating simultaneously and you can't afford to clog up the network.
Yeah, absolutely. So I think there's an issue of network usage. Yeah. I think everyone talks a lot about like 5G. I think 5G really isn't quite here yet. Yeah. And also we think about this in a kind of sort of a Western-centric way, right?
I think there's too much hype around it at the moment.
Yeah, and even if here, Western Europe, the States, it's a bit nearer to coming. There's plenty of places in the world where that's just not a reality or a practicality. I think the other part, I guess, when you think about hospitals and healthcare is the privacy side of things. We don't want to violate people's privacy. We need to secure their data. The EU are going to start fining IoT companies 15 million euros for an on-data breach from 2024. So there's a lot of drive around this. And so Federated Learning, one of its many benefits is the ability to do this very private machine learning on device, and that's applicable across a lot of use cases.
And so what it is that you're offering is a software solution. And so I'm just looking at the back of this label here, and I can see the Python logo. So I take it that your platform supports Python programming.
Yeah, absolutely. So OctaiPipe is built on a set of open standards. It's very extensible. Really what we're offering to the developer is an end-to-end platform that allows you to execute this type of federated on-device learning, but then there is all of the necessary infrastructure to be production-ready out of the box. So we have this EdgeML Ops, which monitors the performance of models on device, monitors the properties of the data that is flowing through the device, automates retraining loops. We automate all of the then contributing actions that link into the federated learning side of things that really drive this kind of continuous learning across a group of devices. and there's all of the infrastructure to do all the good things that data scientists want, their model versioning, metadata storage, container registries and so forth. That's all there out of the box. And the data scientist, for them, it should really feel like they're working in a normal environment. They can work in Jupyter Lab, VS Code, PyCharm, and they can use all of the normal libraries that they would expect to be able to use day to day.
So, if let's say you're a maker and you've created a medical device and you want to try and train AI on these things, what advice would you give to somebody who's new to this kind of sort of enterprise style solution? What advice would you give to them to trying to integrate this into their projects?
Yeah, so I think the first thing is, don't be scared by the FL piece. I remember when I first started reading about FL, I had this kind of like sort of emotional reaction almost as a data scientist going,
I have a lot, yeah.
How the hell can I do ML if I can't see the data, because the data's still on the device. But actually when you think about it, your process as a data scientist is the same, your user experience is just where the learning is executed and how it's aggregated back. The second thing I'd say is that OctaiPipe really gives you a lot of advantage, particularly if you're kind of a new maker and you have a new team and you're an emerging proposition. You want to be able to get from experimentation to production very, very quickly, and OctaiPipe gives you the ability to do that, and it minimizes your engineering overhead because we've automated all of that ML ops process in the back end, and so your ability to deploy production-ready code is very, very fast, it's very scalable, and it's quite robust.
So if a maker was to get into this, who would be the best person to talk to?
Well, myself, my CTO Ivan, who's over there, George, who's our head of BD, who's not here, probably having his lunch. But you could, go to the website, find our contact details, drop us an email, and we're very eager to talk to anyone that's interested. We're pretty passionate about the impact that FL can have in delivering quote unquote better machine learning for these distributed environments. It's really our view that the traditional centralized paradigm of ML is running up against the barriers in the real world. It's all fine in the lab, centralizing the data, but ultimately, there's a better way of doing this, and this is it. Yeah.
Fantastic. Thank you very much for your time.
Super stuff.
So, for the makers who want to go ahead and do medical devices and use distributed AI, OctaiPipe might be the solution for you.